Hi, thank you for watching this video. I'm Alejandro Jaramillo from the Center for Atmospheric Science at the National Autonomous University of Mexico. Thank you for watching this short overview about a recent research where we are trying to understand the socioeconomic impacts associated with tropical cyclones in Mexico under different ENSO conditions, but taking into account social vulnerability. This work is already published, most of the work that I'm going to present today in this paper, where you will find all the methodology, the data, and the conclusions that we found, and you can follow the link to this paper just by using this QR code or this link below. And you are very welcome to ask questions and to write us about more information about this publication. So the topic today is about the tropical cyclones, and a tropical cyclones, as you might know, is a rotating organized system of clouds and thunderstorms that originates over tropical or subtropical waters with strong winds and, very important, very heavy precipitation associated with them. The tropical cyclones are among the most dangerous natural hazards, and here we can see the Hurricane Pauline that landfall in Mexico in 1997 created a lot of damage and a lot of life loss. So Mexico is very affected by the tropical cyclones, and we can see here, for example, the last hurricane season in the Atlantic Ocean and the Pacific Ocean, so Mexico is under the influence of both oceans and the effects of tropical cyclones from both directions. So this is a really important topic for understanding risks associated with meteorological phenomena in Mexico. But also, it's very important to discuss that even though we have natural hazards like tropical cyclones that may affect and create disasters in a certain region, disasters must be understood in terms also of the vulnerability of the society to the different natural hazards. So we can define vulnerability as the social, economic, and physical conditions that increase the susceptibility of communities to the impacts of natural hazards and is independent of natural variability. So it's very important because to understand risks in terms climate risks, we need to understand as a probabilistically function of hazard and vulnerability. So risk is going to be a probability, but depends on the natural phenomena that is creating the disaster, the natural hazard, but also the social vulnerability that the society, if that says if the society is ready to receive the damage by these natural hazards and to recover fast or slow when something happens. So climate risk should be defined as an interaction of atmospheric variables with social conditions. But if we are also talking about climate risk, climate variability must be taken into account, and one of the most important phenomena to to the climate, to understand climate variability in the seasonal to the interannual scale is the El Niño Southern Oscillation, also known as ENSO, that you may know has both two phases associated with the Pacific Ocean, with heating or cooling in the Pacific Ocean, but that has a lot of implications and teleconnections worldwide. And if we study how this ENSO influence, for example, extreme precipitation, we can see that there is a clear difference in, for example, anomalies in rain and extreme days, the number of extreme days. And there is an increase. For example, there is a clear difference between El Niño conditions, that is the positive phase of the ENSO, associated with warming in the Pacific Ocean, and we have a different picture when we are dealing with strong Niña conditions that could be associated like the cold phase of ENSO. So we can see here in these pictures that the anomalies in extreme days changes a lot when we are dealing with one phase or the other. Also, ENSO modulates the tropical cyclone activity. Here, for example, we see an annual average of tropical cyclone density for the different phases, El Niño, La Niña, and neutral years, and we can see anomalies. For example, here in this region of Mexico is higher tropical cyclone density associated with La Niña phase. So this might affect the risk in Mexico associated with tropical cyclones. So we decided to study this phenomenon, and our hypothesis and main objective are we built on previous studies by exploring the tropical cyclone extreme rainfall days under the different ENSO conditions, and we also use the social vulnerability to estimate regional climate risk over Mexico. We hypothesize that ENSO largely modulates tropical cyclone extreme rainfall events in the same way that other tropical cyclone features. And if we take this into account, but also using social vulnerability, we found that ENSO plays an important role in defining the areas with high probability of disasters. And the main objective is to find out the modulation of ENSO on climate risk, considering both a vulnerability index and the probability of tropical cyclone extreme rainfall day occurrence in years under strong ENSO conditions. So we created a social vulnerability index. We use different metrics and we mix these metrics in order to try to cover the most important society factors that might affect vulnerability. We use the degree of local marginalization that measures the extent to which the population has access to education, suitable housing, and medium to high labor incomes. And we also use the social gap that tell us about the social deprivations like educational lag, low access to health service, low access to basic service, and low quality of housing at the local level. Taking this normalized index, we create a social vulnerability index that points to different regions in Mexico that are more vulnerable to this kind of natural hazards. So together with With this social vulnerability index, we take into account, or we consider, a probability of a tropical hazard, in this case the probability of occurrence of a very extreme precipitation associated with tropical cyclones, estimated as a probability of the days when tropical cyclones produce extreme precipitation divided by the days that we have extreme precipitation. So we have clear difference between the different phases associated with tropical cyclone precipitation hazard represented in these panels, and when we combine this with the social vulnerability, we create maps of climate risk that tell us about the probability of how the probability changes under different ENSO conditions, taking into account the probability of a tropical cyclone, but also taking into account the social vulnerability. And if we calculate the anomalies in climate risk, we can see a clear pattern that during strong El Niño years, climate risk is triggered by more than 80% from average in southwestern Mexico, but during La Niña years, climate risk is reduced in this region, but the amplitude is amplified 80% or more than average on the eastern coast of Mexico. Under neutral condition, climate risk enlarged is magnitude more than 40% than average over northwestern Mexico, but mainly in the peninsula of Baja California. So there are different patterns of climate risk for tropical cyclones under social vulnerability conditions, and we wanted to test if this picture made sense. So we estimated, we explore the cost of disasters reported by this database, EM-DAT, that shows us the different, or the costs per state associated with tropical cyclones in the study period. And we can see, for example, that under El Niño conditions, the northeastern and southwestern regions can experience disasters of up to $60 million, while neutral conditions, we can see that more states are affected by tropical cyclones when we compare with the other phases, but mainly in the south of Mexico and the peninsula of Baja California. But if we see the Niña conditions, we see that the cost associated with La Niña, the disasters during La Niña, are the most expensive. So if we compare with the climate risks, we can see that there is a clear pattern, that the two pictures looks very much alike. So this allows us to conclude that there is a very interesting relationship between the climate risks when we take into account tropical cyclone hazard and social vulnerability. So in conclusions, tropical cyclones, we can say that tropical cyclones is a critical phenomenon that cause about 50% of the stream precipitation events, mainly over shorelines of the Gulf of Mexico, Caribbean Sea, and the Eastern Pacific Basin. As I mentioned, during the strong El Niño years, climate risk is triggered by more than 80% from average in southwestern Mexico, During La Niña years, climate risk is reduced up to 80% from average over this region, but its magnitude is amplified 80% more than average over the eastern coast of Mexico. Under neutral conditions, climate risk enlarges its magnitude by more than 40% than average over northwestern Mexico, mainly in the peninsula of Baja California. And if we compare with cost associated with tropical cyclones in the past, we see that under El Niño conditions, the northeastern and southwestern regions can experience disasters of up to $60 million. Under neutral conditions, more Mexican states can be affected by tropical cyclones when compared to the other ENSO phases, and disasters may occur over the northwest and south of Mexico. And under La Niña conditions, the eastern coast of Mexico undergoes economic losses of up to $100 million. Very important, and the key idea of this work is to explore and to make a path for future early warning systems. And for this system, the risks associated with tropical cyclones will be very valuable, but if we take a multi-risk approach. So in these early warning systems, we need to take into account the hazards, but also the social vulnerability. So thank you very much for watching this quick overview. You can contact me on this email, and you might find in the description box below here in YouTube a link to the paper I mentioned. Thank you again for watching this video.